Here, let's look at angles of a polygon. The word polygon means many angles. Poly means many, gon is angles. So a polygon is any closed figure that has coplanar segments. The sides of it has to be coplanar, and they have to intersect exactly two other segments, one at each end point. Each of the segments intersect exactly, so there's no crossing, and no two segments have with common endpoints. Okay, so this would be polygon, this polygon, and this what is not. So this is a polygon, this is a polygon, this is a polygon, but we have convex and concave polygon. This will be convex, where every vertex is out. If you draw a line from one vertex to the other, consecutively, it will not get inside the polygon. This is convex. This is concave, non-convex. So you see, this one gets inside. If you have to draw a line to connect these two endpoints, it's going to be outside. So, but here, to draw any line from one vertex to the other, it's not going to be outside. So these ones are not polygons because this one is curved. This one is not closed. This one is crossed. Okay, so those are the things you look at to identify polygons. Polygons have names according to the number of sides they have. So 3 sides, triangle. Triangle is the first closed figure, first polygon. So 4 sides, quadrilateral. Pentagon, hexagon, okay? And if it n-gon, the number of sides it has, you get that gon, okay? So quadrilateral, because it has 4 sides, 4. Tri, quad, penta, hexagon, okay? There's this song here, the polygons, tri, quad, penta, hexagon, hepta, octa, nonagon, decagon. Sing along, here the polygons, tri, quad, penta, hexagon, or hepta, octa, nonagon, decagon. Right, in the figure, is the figure a convex polygon, non-convex, or neither? Okay, what would you think this would be? Convex, because all the vertices are out. This is concave, non-convex, so because it has holes inside, goes inside. This one is not even a polygon, so it's neither because it has a curve. Okay, this would be non-convex, so it is concave. It goes inside, loops inside. This is not a polygon because they cross, the lines cross. This is a polygon, but it's concave because it has this part goes inside. Okay. Right, here we are focusing on convex polygons. So that's what we're going to discuss in this lesson about convex. Focus on the convex. So these are all convex polygons. It can be polygon can be equiangular, which is when it has equal angles, equal angles, or it could be equilateral, equal sides. Okay, now note down that whenever there is a polygon is equilateral, it does not necessarily mean that it is also equiangular. For example, this polygon, this side is longer than this side, so it is not, but the angles are the same. So it is equiangular but not equilateral. This one, all the sides are equal. This sign shows us that all the sides are equal. So it is equilateral, but see, all the angles are not equal. It has both obtuse angle and acute angles. Okay, so this one, it has all the angles are equal and all the sides are equal. So when it has both, when it is a polygon is both equiangular and equilateral, it is called regular polygon. Regular polygon. If it is a hexagon, regular hexagon, pentagon, regular pentagon, and so forth. Okay, a common regular quadrilateral we know with 4 sides will be a square. A regular triangle we know is equilateral triangle. So also a hexagon or a polygon can be neither equiangular or equilateral. Okay, so regular polygon helps us solve problem very easily. We are going to look at some later. Okay, one of the theorems states that the sum of the exterior angles of a polygon is equal to 360, and that's what they demonstrate here. So if these are the exterior angles, now when you are extending the line, make sure you go on the same direction. So this is going counterclockwise, or if you want to go clockwise, you want to keep the direction consistent. So, and as you watch in the video, you see that if you, wherever this line ends, you know, the rotation did not change. It just held the rotation until it makes another turn. So it made one full rotation of the point, which is 360. Okay, and we use those to solve problems. Another theorem states that the sum of the measures of angle of a convex polygon with n sides is equal to n minus 2 times 180. Okay, and we are going to use inductive reasoning to show that. We're not going to make a formal proof, but just to, you know, show why that is. So we already know that a triangle has 3 sides, and you know, it's drawn like that, and so the number of triangle in it is 1. So the sum angles of a triangle is 180 times 1, which is 180. So we follow that pattern to see how about quadrilateral has 4 sides. How many triangles can we make out of quadrilateral? If we cut the diagonal into half, that would be 2. There will be 2 triangles. So if we, to find the sum angles of a quadrilateral, if we find the angle of each of the triangles, which we multiplying 180 by 2, we get 360. Okay, the next, pentagon, 5 sides. Again, we draw diagonal line. Again, make sure the lines do not intersect. So you draw a diagonal without intersecting. So we are going to make out 3 triangles out of pentagon. So if we find the area, the sum angles of each of those triangles, we'll be multiplying 180 times. We get 540. So how about hexagon? Okay, if we draw diagonal, and you can see the pattern going, continue, we're going to get 4. So we multiply by 4. So how about n-gon? Excuse me. So the number of sides, we can look at the pattern we are seeing here. 1, 2, 3, 4. It keeps going from 4. So how is this related to this number? So we see that, of course, this starts up with 1, the basic. So here, 0 is subtracted. Here, to get 2, we did 4. Okay, it's 4 minus 2. 4 minus 2 gave us 2. This one, of course, is 3 minus 2 gave us 1. Okay, 5 minus 2 is 3. 6 minus 2 is 4. So we can see the pattern. Each one of them, 2 is being subtracted. So if it is n number of gun, going to be n minus 2 also. So to find the sum, since we are multiplying this with all these numbers we get, to find the sum of the interior angle of n-gon is going to be 180 times n minus 2. Okay, n minus 2. So that's how we come up with that formula for finding sum of angle of a polygon. Okay, we're going to use that to solve problems now.